Hello everyone, welcome to 369 Chemistry, and today in this video we are going to do your intramolecular Cannizzaro reaction or internal Cannizzaro reaction. So last time we did using Cannizzaro reaction where we saw that those aldehydes which have alpha hydrogen goes for your Cannizzaro reaction. That means it takes place in the presence of sodium hydroxide, okay, and it gives what it gives you one molecule of your carboxylic acid where the other molecule of alcohol, that means one is reduced, other one is oxidized. So in this case of internal Cannizzaro reaction, here where there was a need of alpha hydrogen, here we need dialdehydes, okay, and alpha ketoaldehydes, okay. That means there should be a keto group which is alpha to the functional group, that is your aldehyde. If those molecule is there, then that is called your dialdehydes, or you call it to be alpha ketoaldehydes. These will undergo your internal Cannizzaro reaction. So when you practice the mechanism of it, so if you take this is your reagent which is given to you, which has two aldehydes, okay, here this OH minus ion, it attacks your electron deficient carbon atom of the aldehydes, because oxygen is an electronegative element and oxygen takes up electron, okay. So this way you draw the mechanism. So here you are getting OH in one side, and this hydrogen we are writing in the downside, so that I can show you the mechanism easily how it happens. Now this hydrogen, okay, this one will go for internal reaction. So in the Cannizzaro reaction, what happened, the hydrogen migrated to the other aldehydes which was there in the reaction medium, but whereas here this hydrogen will go and migrate, and it will go and attach itself to the carbon atom which has the keto oxygen group in it, okay. So this is the hydride shift is internal, it is taking place. So now this O minus, this minus comes into the into forming your oxygen, and here this hydrogen migrates. Now this oxygen which is now electron deficient, it will take up the hydrogen that is also internally among the molecule itself. So this is called your internal you can say Cannizzaro reaction. Now in the presence of H plus, what happens, there is an alcohol group and there is a carboxylic acid on the same molecule. So these are called your you can say two groups are there. One is your alcohol group, okay, that is one is reduced and the other one is oxidized in the same molecule. So that's why we call it to be your internal Cannizzaro reaction, okay. So what will be the IUPAC name of this one? Since it has two carbon atoms, so it will be ethane, okay. So if I say it will be 2-hydroxy ethanoic acid, so that will be your name of this one. So this way if you practice more sums, okay, I will do two more examples to show you this kind of internal Cannizzaro reaction. So these were even used in production of many molecules which are very complicated in nature, okay. So if you know the basic of your reaction mechanism, then you can draw or you can do any kind of reaction which was there in research papers also people do, or you can say which you can do in labs also, okay. So just see, if this is a molecule given to you in the presence of sodium hydroxide, and here it is water, or after that it is hydrolyzed, so what will be your answer? So remember this, here in the presence of OH minus ion, that means you can say a negative an electronegative element, there can be anything, it can be carbon ion also, okay. It does not require that it is always NaOH to be there, okay. That means OH minus is a nucleophile used in this reaction, it is not always so, okay. If you go for higher studies, you will understand that, but for up to graduation this much is enough. So see here, this OH minus ion, here it comes and it attacks the carbon atom, and again one carbon atom is attacked, so you write this OH wherever you are pointing it, and then H is there. So sorry, this should be hydrogen, one hydrogen will be, now this hydrogen will migrate, and there should be oxygen on the carbon atom. I have written it hydrogen, just correct it, it will be oxygen, okay. So now this O minus forms, and there is hydride shift, okay. See, there is a hydride shift, here it will be your oxygen. Okay, and this O minus will now take up the hydrogen from the given, this hydrogen will be taken by the oxygen which is reduced right now, or you can say that carbon atom which is reduced. So that oxygen now it is going to take up your hydrogen. Okay, internally there is a hydrogen transfer, that is ion transfer, which is very fast. This transfer of ion is very much fast process. Okay, so here again there is a formation of CH2OH, that is your alcohol. One side is reduced, another one is your oxidized. Okay, in this one now if in the presence of H plus ion, that is hydrolysis is done, so you are going to get your desired product. So one will be reduced and other keto group or aldehyde group will be oxidized. Alright, so this is the way we have done. We can see another example. So this is a very important example which is given. Okay, so here one is an allylic group and the other one is you have only formaldehyde type of. So now this OH minus ion, it will react with your, it will come and attack the electron deficient carbon atom. Here this oxygen is coming back again and there is a hydride shift. So this hydride shift is making it is reducing the other one and oxidizing the other. So this way you carry on with your reaction mechanism chapter. So just now see, this oxygen is pulling out the hydrogen and this ion transfer is very fast, and it is the same process for all the all the reactions. Okay, it is the same process. So this way we can say if any kind of molecule is there, either it is looking complex, it does not matter. We have to only check the two function group, that is the keto group and the you can say aldehyde group. Thank you so much.